The purpose of this experiment is to find the best tool for a filmmaker to use when lighting a scene with color. We compared LED lights and white light with gels covering it. Our hypothesis is that LEDs are more accurate to the inputs and appealing to the eye when lighting color scene versus using gels. During the experiment, we tested delta UV levels, color accuracy, intensity, saturation, color depth, and color banding when using lights with gels versus using LED lights.
To complete this experiment, we created a vibrant scene in Studio C, then lit it with Amaranth 300C lights, both at 5,600 Kelvin at 10% intensity. For the gel colors, we used Lee 224 Plus Green, Lee 794 Pretty Pink, Lee 105 Orange, Lee 107 Electric Blue, and Lee 106 Primary Red. For the LEDs, we meshed as closely as possible to the respective gel color. Green 96 degrees, Pink 341 degrees, Orange 16 degrees, Blue 222 degrees, and Red 1 degree. For our subjects, we chose to gather different objects of many different colors to showcase how the different types and shades of light affect the colors. The videos were shot on a Sony FX3 camera aimed straight at the subjects. The Amaranth 300Cs were set up about 4 feet from the camera and angled 45 degrees down. Both Amaranths were set to 5,600 Kelvin at 10% intensity. From there, the only variable that was changed was the gel colors for the first part. Each one was recorded for a few seconds in order to capture the look of the scene and use it to compare. Once we finished the gels, we shot the same scene with different corresponding LED colors, also at 10% intensity.
To compare the lights, we looked at a few different factors. We used a Sekonic color meter to identify the delta UV of each color, compared the intensity and saturation of each color, and, in DaVinci Resolve, assessed each light choice for color banding and contrast range. Delta UV is how far a light's color deviates from the blackbody curve. A blackbody curve is a graph that shows the intensity of light or electromagnetic radiation an object emits at different wavelengths. The shape of the curve is found by using the light's color temperature. The smaller the wavelength, the hotter the temperature. These were the delta UV scores for the gels. Lee 224 Plus Green, 0.0238. Lee 794 Pretty Pink, negative 0.0391. Lee 105 Orange, negative 0.0047. Lee 107 Electric Blue, 0.0024. And Lee 106 Primary Red, negative 0.0037. The average gel delta UV score is negative 0.00426. The LEDs didn't have a delta UV score because they don't cast UV light. We found this out after completing the experiment, so we are unable to compare the two in this category.
The saturation of a light is the intensity of a color. When using gels, we often had a lot of white light coming through, making the color less saturated. The LEDs are more saturated because they don't use any white light. However, the intensity of the gels was stronger than the LEDs. There was more overexposure in the gel clips, which makes sense because when using gels, you're able to use all of the white LED chips in the light, versus with colored LEDs where each LED chip is a specific color, so you aren't able to use as many of the chips at once.
Finally, we took our FX3 footage from the experiment and brought it into DaVinci Resolve to color. With no editing, we compared the two. We were looking at the contrast range to determine which lights cause the most color depth, and checking for color banding to determine if the high pulsing of an LED light mattered. We found that the gels had more color depth than the LEDs. There was a wider range of light and shadow, and it was easier to manipulate each extreme when compared to the LED footage. With the LEDs, the color was so strongly saturated that it often took out the white contrast entirely. The shadows were much harder to bring up, and the black point was so intense that we were unable to even see some of the subjects.
We didn't see any color banding in the gel or LED footage, proving that the type of light shouldn't affect your choice when choosing how to light a scene. After these comparisons were finished, we also boosted the saturation and contrast in the gel footage to mimic the look from the LEDs. While the clips now looked much similar, the gel footage still retained its color depth better than the LEDs, keeping the contrast range we mentioned before. So looking back at our 5 categories, let's pick a winner for each one. Delta UV scores were unable to be compared. The LEDs were more saturated. The gels had more intensity. The gels had more color depth. Neither light had color banding. And, bonus category, the gels took more editing to get the desired effect of a full wash of color over the scene. So it looks like they are tied. The end.
Except we wouldn't really end it in a tie. let's look closer at what exactly these categories mean and how they can help you influence your lighting choices as a filmmaker. The saturation of the LEDs was strong and also able to be manipulated. The saturation of the gels wasn't quite strong enough and also couldn't be adjusted at all. While the gels had more intensity, the lights were only at 10%. This means that the LEDs have room to grow and get more intense while still maintaining their saturation, while gels likely have a limit on how intense the light can be before the white light comes through too much for the color to be noticeable anymore. The gels had more color depth, which is important in the editing phase. The LEDs washed the whole scene out and didn't seem to have room to improve just from adjusting the light. However, you could still use other fills and diffusion to adjust the scene to your preference. LEDs also have the advantage of being a more modern tool. They are more accessible and function more quickly than gels. So, while both tools can color a scene effectively, we decided that LEDs are the favorable tool for a filmmaker.